Welcome to the November 18th Jalen Zones production user call. We have Goran, Jan, Jamie, Dave, and myself, Michael, so far. Happy Independence Day, Latvia. There's a linked video. I put my Latvia name there because, hey, there's a video that shows the event my wife and I put on Sunday celebrating Independence Day and the 75th anniversary of our center. And we were discussing before the recording some 15.0 issues. I see most of the items on the metabug have been removed. And Dave, as you maybe are trying to type in parallel, maybe you've got some updates for Podman. I'm happy to. Oh, you've got a link. Yay. You can make that land and we'll go from there. I'll open that bad boy up. Let's see what you got.
Oh, do you want me to start with that, Michael? Yeah.
Oh,
That
sure. This is exciting. What you got?
Uh, so I'll start with the tools first. So as part of some work-related stuff, I've been just going through various tools in the Podman world and testing them and seeing how they go. So one of them is a new port that Gleb did, which is Podman Desktop, and it's pretty neat. It's just imagine start and stop GUI buttons from a desktop app for containers, and it works just like the tool. That's pretty neat. The other one is using Ansible. So Ansible has a Podman library, and so far all of the functionality I've tested, and it just works out of the box, pointing to a remote FreeBSD box running Podman. And the last but not least was the Podman REST API. So there is a daemon that you can run as part of Podman. It's called the Podman service, and it provides a REST API to starting and stopping containers. And so far, that's pretty cool. So I'm working on some integration stuff for that at my day job, and we hope to open source that later in the year, maybe early next year. We'll see. So those are cool things to have a play with.
On that first tool, just quick question on the first one, is it rather portable?
It's ported. Sorry, that was the thing that Gleb did.
So is it in Go or Rust or
SQL,
C
Pod,
or
desktop? Oh, it's in all of the. I don't know what it's in. It's an Electron app, so it's probably a Node.js front end wrapped in an Electron app. Ports. Thanks. Here we go.
Cool.
There.
Nice. Thank you.
Yeah. So on Podman port. So number one is for 15. I want to finish my get started with Podman and FreeBSD bit for the handbook. But once that's done, I want to have around 15 to 20 FreeBSD native Podman containers that people can riff off or refer to. And that's kind of that Christmas project where you've got like sort of 2 weeks sitting at home, eating cookies and avoiding going outside, but time to hack in discrete chunks. And all the usual things. I'll do a Postgres and Nginx, an HA proxy, a couple of other things that I use, and look at HedgeDoc. And there's a couple of other things that are interesting, Uptime Kuma, and another one that I forget, these types of things. And it should be enough for people to run. Caddy is one of the other ones, for people to run a useful container, serve web stuff, and hook up a database to it. And that should give people an idea of the more tricky things: how to build a container file that uses FreeBSD build chain, how to mount data volumes so that your persistent data can live outside the container file system, and how to handle secrets and networking. Those are the main things. And there's a large document about that. It would be great to have some comments, and you all know how to do this, so you can add some comments and take it from there. Yep. Questions?
I think would be a neat example case to handle a Postgres major version upgrade.
I don't think I want to put that in the container thing. Like, I'm happy to provide a Postgres container, but why would I want a version upgrade?
So let's say someone starts their production setup with the default FreeBSD Postgres version now, right?
Yeah.
In a year or two, maybe the default version changes to the next release.
Yep.
Then all the packages are built by default for that version. And so you want to have some kind of Python package so that you can talk to it. We have a client that depends on that library, so stuff has to be in sync, or you want to have the new features.
Right. So this is solving the perennial problem that I can't have two versions of Postgres installed at the same time.
But with the data volume, you can make some things happen. You can use a change root environment, so you don't even have to use nested jails. Especially now that you can just set it up correctly, get a NullFS mount, whatever, or just do it the old-fashioned slow way and do a dump restore, but just show people that you can automate the migration of persistent data. And I think kind of take the fear away that stuff will get lost or locked to a specific container version.
Yeah, that might be a stretch goal. Goal one, have enough that people can do useful things. That's maybe like an advance. It's a good idea. Interesting. I'd have to think about how one would do that. You'd really have. Yeah.
But I think if you can show how this can be automated, then you've kind of shown, okay, this is ready for real world deployment. And the other thing is that you can just, for the basic things, look at the Bastille BSD template collection. I dropped the link into the chat.
Yeah, I see that. Yeah.
They have kind of how to set up random stuff. I don't know, an Apache server, console, like Grafana, or a Firefox in a jail.
Yeah. I'm not sure we could do out of the box.
Firefox not, but
I think we need some extra stuff for that.
Yeah, to make it usable, you do. But for stuff like Grafana or an HA proxy, whatever you want.
Yeah. Anyway, that's the idea. Have some sort of prepackaged stuff to get people started. The Bastille stuff is very similar to what I had in mind. The big difference here is, or what the big question is, do I do these in the ports tree, which has pros and cons? The pro is it's already coupled nicely to the ports. So the people who are maintaining ports today can have a container file that matches. The con is you can't do things like hedgestock, which aren't in ports. And I don't intend to bring it back to ports because the packaging of Node.js stuff is just so horrible, but it's ideal for containers. So pros and cons.
Interesting.
Please add your comments to the document and I'll let it stew for a couple of weeks.
Which document?
The one I linked to. What would we call it? Podman imports. I should call that containers imports, actually.
Just drop it in chat, please, the link.
Yeah.
Or is it in the document?
It's in the document.
Oh.
Dave, is there something?
So I think that the OCI container are their own thing. They do not really belong as don't deserve the wrapping port or package because they have their own registry already.
Well, they don't have their own registry that in that sense.
They have their own registry protocol. You have the whole.
Anyway, you can read the document, put your thoughts in at the end of it, but I sort of cover both. Yep.
Dave, is there on Podman registry, is there a FreeBSD official account?
Yeah, so I don't know about if there's a specific Podman registry, but we've got Docker Hub and what's the other one? GitHub container registry for both of those.
Perfect.
Yeah, and that would be my suggestion, is that we would push those periodically up to the same place.
On that note, could you paraphrase this recent headline for our listeners?
Okay. So the OCI spec that Doug has implemented and ported to FreeBSD is an open specification that covers, at the moment, Linux, FreeBSD, and at some point, I assume Windows. I don't know if that's actually being worked on, but it's designed to be open and compatible across operating systems. And within the broader Open Container Initiative project, there are a bunch of specifications. One of them is an image specification, which Doug has implemented, and the other one is the runtime specification. And so for the runtime specification, this effectively is with jails on FreeBSD. There are actually two implementations of this. So one is the one that Doug has implemented for Podman, called OCI jail, which is actually in C++. And the other one is RunJ from Samuel Karp, who is a longtime container guru, I think now at Google, previously at Amazon. And both of those are imports, and you can use them to run containers. So the runtime specification is the translation layer between the metadata in the image and how the runtime actually implements this, which from our perspective means jails. You could in theory do a beehive flavored one, I guess, when you could do a cheroot one as well, if you like. And this has taken, I think, 2 years to wend its way through the specification process. So it's pretty cool to have this officially recognized.
Thank you. That was precisely what I was after. Cool. So that said, lots of great news there. Goran, you were looking at Kqueue and jails. Would anyone like to answer any questions you might have?
I still don't have questions. I'm playing with the Kqueue side only. My Christmas hacking ritual included C++ and sound. So I came to a point where I experimented with Kqueue and kernel implementation of a sound, which Richter perfected and merged. But it does have some bugs, and I'm currently looking into it, but I don't know if I'm gonna solve it. Anyway, my goal is to document the Kqueue, which is alternative to other polling system, but in my humble opinion is the best alternative out there, because it can track or poll for processes, for jails, since relatively recently. It can track sockets and whatnot way more than select and poll can, and I think even epoll on Linux, but I haven't used it, so I'm gonna refrain from comments there. Anyway, the idea is the Kqueue is a wonderful syscall. It's just very hard to find how to work with it, especially in the kernel space. So, although it's not strictly jail related, uh, the bug on sound will probably tell us something about how to handle Kqueue, and maybe I'll be able to check something in jails. with the new knowledge. But yeah, Kqueue everywhere if you ask me, and but to get there, people must have some examples and documentation of how it's done in the user and kernel space.
How does that relate to kevent? There's a question in the chat.
It's the same thing. Practically, you have key events that are put in a Kqueue.
Okay, got it. Yeah.
I was asking because the Kqueue system call itself is fairly trivial. It gives you the queue, but then all the modifications and notifications are delivered via the kevent system call. I was wondering if you actually meant the system call or all the data structures behind it. That looks like all the data structures behind it.
Well, the data structure in a user space is pretty much documented. I think for user space only, maybe a jail example would be sufficient, and that would be it. For the kernel side, I read all the white papers I could find, and the number is two. And I couldn't find anything more than in the kernel space, the knote is used and klist, but
Mhm.
I didn't get much more than that. So
That
most of my knowledge comes from reading Queue's implementation and how it handles the key events and Kqueue. And even smaller patch at the first, I think PSM, the mouse. So it has a much simpler Kqueue implementation, and that was suggested by me. I forgot by whom, and I don't have an email in front of me. But yeah, in short, why the Kqueue is important is because, in my opinion, two things. It scales better because select and pull or passing the whole list of events we're interested in every call in a loop, and that's really slow. With the Kqueue, you kind of configure it and let the kernel remember what you need, what you want to be notified about. So it's faster for a big number of file descriptors. And the second thing, there's a big difference is in white papers, it's described that it's edge-based, meaning that it's gonna, if you event every time there's a change of state, not when the state is such that there is data in it or data ready to be written to, which is select and pull. Why is that even important is in situations like when you're memory mapping your file descriptor and you want to be notified about the ability to read from it or write to it. Select and pull do not mix events for those, so you cannot know, and you have to calculate the time. If it's something like sound, and every sample has a time duration, and then you ask your device, hey, when are you going to be finished in this many bytes, which is this many samples, blah blah blah. But yeah, the Kqueue makes it all for me easier to work with, and really boils down to a few lines of code.
Cool.
Yeah, in the as far as I understand, basically all the common Kqueue filters are level triggered, so they kind of latch the change. You're not expected to always immediately consume something and otherwise drop it, because just like edge triggered interrupts. Level triggered interrupts are so much easier to deal with. Same with event notification. And you can set a flag so that you explicitly have to take receipt of the event. Otherwise, when the event gets delivered to user space, it's normally but implicitly cleared. And all of that happens atomically, so that if you take a receipt of some event and it happens again, you get a new delivery by default. But you can set one shot as well in user space. So yeah, you can handle the exotic cases if you really need to.
Michael, can you just add knote and klist are used in kernel space?
Yeah. But user space can ask for all of these strange corner cases. And
My impression was you were saying that's the documentation available, but I can remove that or whatever works.
Oh,
yeah,
no,
but we
just
have a
after, just before, but knote and klist are used in kernel. In user space, it's kqueue and kevent.
Ah, okay.
yeah. So yeah, we have both a k-event data structure and we have the k-event system call with the same name, struct k-event, and the function k-event, which eventually performs the system call k-event.
Cool.
But all of this, if I understood Goran correctly, what he wants to document is how to implement this in kernel. So if you want to add a new filter, so that you don't have to reverse engineer the existing implementation and learn from those. So
Well,
that
the
the next,
kernel space needs more documenting than user space. But for example, at this point, I don't even know how to use the Kqueue with Jill, and I don't know where to read about it except in the kernel was implemented, then in my head transfer it to a user space code. Because
so,
actually what we have is that klist is kqueue, just klist is in the kernel, kqueue is in the user space, and kevent is the knote, and they share some fields as structures in C. So it's almost one-to-one. And I can figure out reading the kernel code what I need to do in user space. It's just it would be nicer if I could avoid that step.
So is
Oh
there a
yeah,
canonical tool that produced this that you can look at? How did we receive these with so little documentation?
I don't know.
Like network device handling or something, like hot pluggable goodies? Like there must be a backstory.
How did we get to the Kqueue implementation? Or
Yeah, something motivated it. Someone went to a lot of trouble.
oh yeah.
Something must use
They
it.
are they are much more optimal than select and pull, which are all the alternatives on FreeBSD. The speed comes only if you are trying to watch many file descriptors or process IDs or whatever you are tracking.
Hmm.
Because for a handful, it's not gonna show some speed improvement, but maybe for a high traffic load balancer where you load balance a lot of people to well, a lot of servers potentially, then you're going to open and handle a lot of file descriptors corresponding to the sockets.
Okay.
And in those cases, I think around 1,000 Kqueue already shines with 1,000 open sockets. With 10,000, select and pull are using considerable amount of time to just find you the event you were looking for. Not even deliver it to you, just to
Hmm.
gather the information what you want. So with the number of file descriptors watched, the KQ becomes more and more optimal. Well, select and pull become less optimal. The KQ is almost linear, uh, judging by the graphs in the papers. So the paper was done by. Oh, you already have a link.
Yep.
Okay.
Yeah, I'm doing a little research
Uh,
here because, hey, it had to come from somewhere for some reason. So let's see, at least the article might be handy. And I do see, say, OpenBSD manual pages coming up, etc. So I don't know if it's, can you actually turn to other OSs for examples to snarf?
So the
I tried, sorry, Ann, I tried to read out NetBSD, OpenBSD, and macOS also have the KQ support. And I tried to read those man pages, and practically, I think they all forked it at some point.
Hmm.
I'm not sure if KQ is, I don't know, older than OpenBSD and they forked it all together, or they ported later. I don't know the history. But yeah, it's the
so
madness. Yeah, that paper is quite. Quite good for user space, and I think we should have
mhm.
something like this either in the man page, or if the example is too long, maybe in the handbook. I don't know.
So NetBSD at least used to have a hack built into their poll implementation. If the poll set is large enough, they will use the MMU to set the poll mapping read only, and then only if you modify the watch set again, they take a page hold and re-index it so that they kind of keep an index cache of your poll data, so that if you have a large enough set of file descriptors to watch, suddenly poll becomes fast again for common users, which yeah is a crazy hack. Which really makes the kernel a lot more complicated.
Hmm.
And it's kind of, you're relying on this fairly obscure optimization at that point. I think it's if the poll set is twice as large as the page size or something,
Hmm.
where they start this optimization.
Okay, going straight to the introduction. What motivated this? Short of better, but
The
not.
C10K problem.
Yeah,
So
okay.
10,000 TCP connections to one process,
Hmm.
which select by default can't do because the bit set is normally limited in the C API, even if the system call can deal with larger bit sets. Uh, Paul doesn't have any arbitrary size limits, but it's still slow because it requires for every round trip through the kernel, when you do a poll or select, the kernel has to linearly scan the argument. So you give it an array, or in the case of select three bit sets, and which are basically three arrays of bits. The kernel has to scan them, find the file descriptors you need mentioned, and then
Hmm.
build up the list in with Kqueue or on Linux epoll or on Solaris devpoll. You can create this data structure in the kernel where you have all your reservation, and then it's stateful, so you don't have to write the whole set of what you're interested in on every system call. And because of that, it scales a lot better to lots of event sources. The other advantage with Kqueue is that Kqueue can handle things other than file descriptors, even if these days a lot of them can be wrapped around as a file descriptor. So you can watch for signals, you can watch for processes and stuff like that. So that gets you to the mythical unified event loop, where in user space, a thread can have a single event loop without active polling, which can watch all the event types the kernel cares, the user space process cares about from a single kernel thread. So you don't have to have one thread handling signals, one handling child process, another one handling this, and then coordinating all of that again. But instead, you can watch all the event types with just Kqueue. That can really make code cleaner and
So clearly
simpler.
something must be using this every minute of the day. So what's that subsystem that warranted this better mousetrap?
Well,
Unless it
if
was
you
purely
read the,
academic.
no, when I read the paper, it was
Yes.
mostly about sockets. So
Okay.
probably started with sockets and encompassed everything else that it does today, jails and processes being one of the subsystems that, or one of the types of events that you can be notified about.
So do we know what their
Uh,
socket heavy application use case
Web
was?
servers,
Web service. Thank you. There, that's the first.
yeah, anything network related.
Got it.
anything which could be a SOX proxy, could be HA proxy, could be Nginx.
Yeah.
Okay, it didn't exist back then, but something like it. Any kind of uh, server which wants to serve lots of file descriptors without using lots of threads.
Got it. Thank you. Okay. Any other topics, questions, ideas, concerns?
Really
Independence
quickly,
Days?
just
Yes.
one more thing is that KQ tells you how big the data is that you're about to read. Select and pull don't tell you that.
Oh,
So you
okay.
can pre-allocate enough memory to read everything from that socket, for example, or I don't know, a process, ID, whatever
Mhm.
you're tracking. Mostly dynamic stuff comes from sockets or file descriptor alike devices because they can be kernel interface to the kernel module. But anything that can be represented with file descriptor is usually dynamic in nature. So sometimes I'm going to send hello, sometimes I'm going to send hello world. And the KQ is gonna tell you, hey, not only there is a new event, but in order to copy that event from kernel to user space, you're gonna need this amount of memory, this many bytes. So you know before the event, usually well, not usually, sorry. With select or poll, you're going to read in chunks like 1 kilobyte of memory, and if it's bigger, you're gonna do it in a loop. Here you can pre-allocate the buffer and then just maybe even read in chunks, but still you're gonna allocate just once because you know how big of a buffer you need.
And you can pick if you want, for example, to use for short messages an on-stack buffer and the big buffers you allocate on the heap or stuff like that. And the other nice thing is you can also specify a threshold so that the kernel is only supposed to wake you up when you have like one protocol unit of data worth in your socket buffer. So if you have low connections, you don't get notified every time there's a packet arriving and you know you need 32 kilobytes to form a record in your application. You can tell the kernel, hey, I want only to be notified once you have 32 kilobytes worth of data because otherwise I will only copy it into another buffer anyway until it's ready.
Fantastic. Очень хорошо. Принести. Great. Anything else? That is the best description of KQs and K notes and goodies I've heard yet. That said, Dave, would you like the honors?
I can never remember what to say. Sorry.
Any closing greeting? I don't get too hung up on likes and such because YouTube always moves the metrics on whatever goal they bless as some new level of publication. So
All right.
say whatever you please to the kind people.
Thanks for coming to our prison. Like and subscribe.
Thank you very much. The bell's a nice touch.